Have you ever wondered what's really going on inside one of those buildings where medicine is made? It's kind of a hidden world, and it's governed by an incredibly strict set of rules. So today, we're going to get a special inside look. We'll be using the European Union's official safety blueprint, the Good Manufacturing Practice Guidelines, to see exactly how every single medicine is protected step by step.
You know, this whole massive blueprint really boils down to one central question. How do you build a fortress against contamination? Because that's exactly what a pharmaceutical facility is designed to be, a fortress. Every wall, every pipe, every procedure is a carefully planned defense mechanism to protect the medicine inside. So a fortress this complex has to be built on a solid foundation, right? And it is. The entire thing is built on one core principle. You can think of it as the mission statement that governs everything, from the architectural plans right down to the daily cleaning schedule.
What's so important here are those two specific goals: minimize human error and prevent contamination. That's it. Every single rule we're about to walk through is designed to serve one of those two critical objectives. It's all about making the system as foolproof and as clean as humanly possible.
Okay, so let's start our virtual tour. And just like with any good fortress, the defenses don't start at the front door. They start on the outside, with the very ground the facility is built on. This first layer of defense basically treats the entire building like a sealed bubble. A little crack in an exterior wall, that's not a maintenance issue. In this world, that's a security breach. The location, the cleaning, the pest control, it's all designed to completely isolate the facility from the outside world. And unauthorized people, absolutely not allowed.
And that level of control extends to things you can't even see, like the air itself. Every element, the lighting, the temperature, the humidity, the ventilation, is controlled with incredible precision. A temperature that's off by just a little bit could ruin an entire batch of ingredients. Too much humidity could grind production to a halt. The goal here is a perfectly stable internal environment where absolutely nothing is left to chance.
All right, now we're stepping inside, into the heart of the facility, the production core. This is where the medicine is actually being made. And, as you can imagine, this is where the risk of contamination and the defenses against it are at their absolute highest.
In here, the primary enemy, the main villain of the story, has a name: cross-contamination. This is public enemy number one. It's the risk of a microscopic particle of one medicine getting into another, which, could have devastating consequences for a patient. The entire design of this area is a masterclass in making sure that never, ever happens.
So, how is this inner sanctum defended? Well, for starters, the layout is designed like a one-way street for production. This prevents mix-ups and backtracking. But the real genius is in the surfaces themselves. Every single wall, floor, and pipe is engineered to be perfectly smooth and seamless. This leaves absolutely no crevices, no cracks, no place for a contaminant to hide. It's an environment that's actively hostile to dirt.
But what about really high-risk materials, things like certain powerful antibiotics? Well, for those, the risk is so great that even these extreme measures aren't considered enough. The only solution is the ultimate one: a completely separate, totally dedicated building. It's literally a fortress within the fortress, guaranteeing zero possibility of cross-contamination with any other product.
Now, the production core is amazing, but it can't operate alone. It relies on these critical support areas. Think of them as essential wings of the facility, and each one has its own set of strict rules, all designed to protect that central core.
First up, storage. Now I want you to erase any image you might have of a dusty, old warehouse. That is not what this is. This is a highly controlled environment designed to protect every single material from the moment it arrives to the moment it leaves as part of a finished product.
This whole controlled environment is built around the idea of quarantine. Every single material that arrives is treated as guilty until proven innocent. It's immediately isolated, locked down, and sampled. Nothing gets cleared to enter the production area until the quality control labs give the official final green light.
And speaking of that green light, that brings us to our second support wing, the Quality Control Labs. This is the scientific command center of the entire facility. And to make absolutely sure its results are completely unbiased, it is always physically separate from the production areas.
The labs are designed with that same obsessive attention to detail we saw in production. The layout is all about preventing mix-ups, and super sensitive instruments are shielded in their own rooms to prevent any interference. Every rule here serves one purpose: guaranteeing that every single test result is accurate and trustworthy.
Okay, our final support wing covers what are called ancillary areas. Now, this might sound a little boring, but stick with me. You'd think a break room is just a break room, or a workshop is just a workshop, right? Well, not in this blueprint.
The logic here is just total, uncompromising isolation. Restrooms and toilets can never, ever open directly into production or storage areas. Even the maintenance workshop has to be kept separate. And why? Because anything that isn't directly part of making the medicine must be physically walled off from the clean core. It's all about preventing any possible source of contamination.
So we've designed the building from the ground up. We've thought about every room, every surface. But what about the tools and machines we put inside it? Well, as you've probably guessed by now, the equipment is governed by the exact same strict principles. This right here is the golden rule for any piece of equipment. Let's put it in simple terms. Any part of a machine that physically touches the medicine has to be completely inert. It can't react with the product, it can't add anything to it, and it can't absorb anything from it. The machine's job is to make the medicine, not to become part of it.
These rules follow a machine through its entire life. It starts with its design. It has to be easy to clean. Then it moves to its strict calibration schedule to make sure it's always accurate. And if a machine breaks or becomes defective, it's immediately taken out of service or clearly labeled. In this system, there is zero room for error from faulty equipment.
Okay, we've just toured the entire facility, from the foundation all the way to the individual machines inside. Let's just take one final step back and see how all these thousands and thousands of details actually come together.
And this is the ultimate takeaway. Every single rule, from the smoothness of a wall to the specific label on a tiny pipe, is a deliberate, calculated step. All of these details work together in harmony for one profoundly important reason: to ensure that the medicine we and our families rely on is safe and effective every single time.
I mean, it's an incredibly detailed, incredibly demanding blueprint, which leaves us with a final thought to chew on. In a system this complex, where every single step is designed for safety, what is the real cost of taking just one single shortcut?